project. Okay, so first here we have motor driver module to drive our motor and to manipulate the speed of our pump. And here we have 12 volt battery as our power source. Next, the driver motor module, we will connect it with the Arduino Uno. This is LCD to display our result, and this is board and male and female wire to connect all the components. Next, this is how we will set up our tank. Here we have pump, pipe for the water flow, and here we have float switch water level to detect the level of water. For our first setup, we only use 2 float switch water level, which is one to detect high level of water, and this one is to detect low level of water. For our first setup, we cannot determine the level of water between the high and low water level. So we decide to use water level sensor. So we can determine the level of water in the middle part. After the second setup, we determine that the water flow in is not equal to water flow out. So we decide to add one more pump so that the water flow in will increase and is equal to the water flow rate out. After our third setup, we decide to improve more our setup since the problem is the water level sensor that we use. It has small range of detection, and it also gives inaccurate result since the water level read by the LCD is fluctuate. So we decide to remove the water sensor level and we use sonar. Since sonar can detect all the level depth that we want. So this is our final setup.
first of all, this is the latest and final coding for our project. Okay, this is derived from other sensor that we use and other setup. So this is the final one. So first we have the LCD coding, and next is the float for our calculation part for the duration, distance and level. So float is used to have a better decimal point. Okay, next this is the button pin used for the float switch at the top for the emergency. This is the water pump for the PWM to drive the water pump at different speeds. Okay, next is the setup. The setup of the LCD. Okay, we have the setup for the sonar. And next, this is the setup pins for the motor driver for the pump. And this is at the initially at the setup we have the pump speed at 0, both of them. We are using two pumps. Okay, next. Okay, this is the coding where we find the distance or the level from our tank. So first we have run the sonar at 0 button, so we have determined the level is 70.5 cm. Okay, next this is the coding for the pump. This is running both is running at both of the pump is switched on at the highest at the first loop. Okay, so next the coding, the first if at the button state is low. Okay, the button state and the button state is this one. This is this button. So when it's at the most top position, it is as low, which means the water is already at the high level. So after that, both pump will be off, and then will display water level is full. Okay, next we have when the level is less than 5 cm, we have both pump running at full speed. And next, at level more than 5 and less than 9 cm, we have one pump running at full speed and one more pump running at 50%. Okay, and next is level more than 9 cm and less than 15 cm, which is pump is running at half speed 50% and pump B is switched off. Okay, next this is our delay. At the reading for the LCD and our serial print we will get in every 1 second. Okay, that's all for the coding. Thank you.
Okay, next, this is the results we obtained for our project at time and YM. So to analyze our result, we use non-linear regression to calculate y hat as theta 1, as theta 2, error and error square. So this is our graph that we have obtained. This is graph of ym and this is graph of y hat. And then by using solver, with the summation of e square equals to 0, we obtain the value of k, tau and theta. So the value of k obtained is 0.1616, tau is 2.117 and theta is 30. From the graph, T1 is 42 and T2 is 748. And theta 1 we got from T1 is 72 and theta 2 is 778. The value of m that we have used is 18 and 31.
Okay, next we create the simulink loop, simulink. So this is the simulink that we get, and the first one is the step, PID controller, the transfer function, the time delay, and the result that we obtain. So in the PID controller, the P proportional value is KC, which is 1.91619, and the integrate we get by calculating KC K divided by tau I, which is 0.09524, and the derivative value we get is from KC times tau D, which is 2.8575. So this is the PID controller. Then in the transfer function that we get is by 0.1 is the K and the tau is 2. So the transfer function is 0.1 over 2s plus 1. The transport delay is the time delay that we get is 30. Okay, so this is the graph that we get from the simulink that we create just now. So the graph is response versus time in the range time 0 to 2000, and this is the step the project that we get.